We're now going to have a look at adding and subtracting algebraic fractions. And we're going to refer back to the normal fractions that you should all be very familiar with now. So I'm going to look at normal fractions and then compare that to algebraic fractions. The big secret is they work exactly the same. So examples of a normal fraction would be when we have something like 4 over 5, or we have a third, or we have something like 36 over 19. That's normal fractions. What is algebraic fractions? Algebraic fractions have a numerator or a denominator that contains pronumerals. So it can be something like 3x over 7, or it can be 4 over 9x plus 2, or it can even be 7x minus 4y over 3m plus 2n. So all of these are algebraic fractions because they contain pronumerals, normal fractions. Okay, we are not going to concentrate too much on these ones in year 8. We will do a bit more of that in the higher levels. We're currently only going to look at these when it comes to algebraic fractions. The principle is exactly the same. So if by some chance you run into one of these in a problem-solving question, the rules stays exactly the same. Okay, so the first thing that we're going to do is we're going to look at when we add or subtract the fractions. And let's say they give us something like 2 over, I'm going to use the wrong pen. Let's say they give us something like 2 over 7 plus 4 over 7. How do I do that? Well, we know that we can only add and subtract when we have like fractions. Okay, and it's not like fractions because they taste good. It's like fractions because they have the same denominator. Right, so the same denominator determines what fraction it is, and only if they have the same, then I can say 2/7 plus 4/7 equals 6/7. Okay, how does that compare to algebraic fractions? If I say 3x over 8 plus 4x over 8 equals. So these 8ths plus these 8ths, as long as the two denominators are the same, I just add my exponent. I'll just say 3x plus 4x equals 8. And remember, 3x plus 4x, if these are like terms, I can add them up. And if I add up those, it becomes 7x over 8. However, if this was an m and an n, or an x and a y, remember you can't add 3x's plus 4y's because they're not the same, and that will be the simplified form. I think I'll do the next example using one of those. Subtraction exactly the same. I can have negative fractions. If I say, what is 1/5 take away 4/5, my answer will be 1/5 take away 4/5 will give me negative 3/5. Bases have to be the same. The denominator, sorry, needs to be the same. The same thing happens here. If I have, let's say, 4x over 11 minus 3y over 11, my denominator is the same, so I can write them over 11, and then I just subtract the numerators, 4x take away 3y. Now you can't take 3y away from 4x and give an answer because you don't know what x and y is. They represent a number that we don't know what it is. So this will be as simple as it gets. So you can't simplify that any further. Now, I'm going to change colors. I'm going to go to blue and a lighter green. So when we have, if we say 2/3 plus, let's say 3/5. The only way we could do this is if we found a common denominator. So we looked at the highest common denominator. We said the highest common factor for, the lowest common multiple for 3 and 5. The LCM for 3 and 5 is 15. Okay, and then I said, how did I get from 3 to 15? I multiplied that by 5, and I multiplied that by 5. How do I get from 5 to 15? I multiplied by 3, I multiplied by 3. This will give me then 2 times 5 is 10, plus 3 times 3 is 9. So my answer would have been 19 over 15. I had to get my denominators the same. If I have this in x's and y's, so let's just change to this. So if I had a question of, say, 2a over 3 plus 5 or b over 5, it's exactly the same. I can only multiply when I have the same denominator, so I have to get the denominator the same. Lowest common multiple for 3 and 5 is 15. What do I do to 3? I time it by 5. What do I do to 2a? I multiply it by 5. What am I doing with 5? I multiply it by 3 to get to 15, so I have to multiply that with 15 as well. Now, it's going to give me 2a times 5. 2 times 5 is 10a plus, and b times 3 is 3b. I cannot simplify. I can't add that up because they are not like terms. Please don't cancel that 3 with 15. Don't do it. You can't simplify that way. So once you have more than one term at the top, they cannot simplify with anything at the bottom. That's how we're going to write that. That's as far as it goes. Please look at the other examples to make sure that you understand this topic.